Apache Kafka is an open source distributed event processing or streaming platform that allows applications to process large amount of data quickly. It is one of the most popular messaging systems for distributed applications. To understand how Apache Kafka works, let's take this example. Let's say I want to track the updates from different soccer matches happening at the same time, and I want to show the updates on different devices and platforms. On the left-hand side, I have the source of the updates, where I want to get the data from. It is called a producer that produces data or information that I'm interested in. In our example, updates of the soccer matches. On the right-hand side are the applications that would use or consume the data, and they are called consumers. Examples like an app, a website, or notification center. Updates or information may be related to match time, players, goals, scores, number of penalties, number of red or yellow cards, offsides, and any other game updates. Every single update that I want to track is called an event. An example, if I want to know the number of goals, every time a player scores a goal, this is an event happening. An event is a record of something that happened. Now, in order to know which team scored, I can organize it by team name. Every time a player from Team A scores, then I can log that event under Team A section. The same thing for Team B. Now, the same concept applies for any events or updates coming from each team. They are also sorted by team name. That covers goals, scores, players, etc. And this is what we call a topic. A topic is a collection of related messages or related events. It is Kafka's fundamental unit of organizing events. A topic is a sequence or log of events. In our case, events related to Team A are logged inside that topic. Messages in Kafka are organized or categorized into topics, and each topic is given a name. Topics are additionally broken down into several partitions. A partition is a single log. The number of partitions is specified when configuring a topic, but the number can be changed later on. In the example you see on the screen, we have 3 partitions for this topic: partition 0, partition 1, and partition 2. Messages are written to partitions in an event-only fashion. Every time an event happens, it gets added into the topic partition at the end only. An example, if Team A has already one goal, and then another player from Team A scores a second goal, then this gets added into the topic partition without deleting the previous information. The first goal has already happened. And this is one of the fundamental features when using Kafka, that events are immutable. Once an event has happened, it cannot be changed. An example is a financial transaction. Like if you deposited a check, this event does not disappear. Instead, an additional event is written to the stream of your financial transactions. Another example is when a customer returns a merchandise to a shop. We don't delete the fact that the merchandise was sold to them earlier. Rather, we record the return as an additional event. Now, in order to know where to add the event, like is it going to partition 0 or partition 1 or partition 2, this is specified using something called a key. When an event is added into the topic, it comes in a pair format. It has a key and a value. Think about it like an envelope, that it has a value inside and it has an address to know where to go. The key is to know where to add the event to which partition. And the value is the data, the information of that event. In our example, if there is a goal or not. If we're using binary terms, 1 or 0. The producers make the decision to which partition the message is going to. So once the producer specifies the key, let's say for example the key is partition 1, then using our example, every time team A scores, this would go to partition 1. Now you can give the key different names related to your application. For example, the first match, that every time team A scores in the first match, then we keep the updates in partition 1. So this would give you the assurance that within Kafka topic, messages having the same key always land in the same partition and therefore always in order. So if the order of events matter, then use a key to preserve the order and to keep track of the updates. An example, if you want to keep track of client financial transaction, like they deposited a check first, then they withdraw some cash, then they use their card to purchase something. In this case, the order matters. I need to know the sequence for this client. If a message has no key, then the messages that you will write into the topic will be distributed round robin among the topic partitions. Using our example, if no key is specified, then once team A scores a goal, that would go to partition 0. The next one would go to partition 1, the next to partition 2. If there is an extra goal, that would go back to partition 0, then 1 and 2 again. They are distributed evenly among partitions. Each message in each partition has a unique offset space, starting from 0, 1, 2, and they keep increasing forever depending on the number of events for that specific partition. Once the event gets added into the partition, Kafka sends an acknowledgement back to the producer confirming that the message has been added. So the next event is going to be added in the following offset within this partition. Thanks for watching, and please like and subscribe to my channel for more videos on SCADA, PLC programming, and industrial automation. I'll see you next time.